tangent of the angle of slope and perpendicular lines. Now we should remember that tan theta equals opposite over adjacent, and that the gradient of the line is y2 minus y1 divided by x2 minus x1. And therefore we get a new rule, m equals tan theta. Now this is one that you will need to remember. Theta is the angle that makes the line makes with the positive direction of the x-axis. So example 1 says determine the gradient of the line passing through the given points and the angle the line makes with the positive direction of the x-axis for these 2 points, 430 and 68. So let's work out the gradient first, because we'll need that to work out, it tells us to work out the gradient of the line. So we have y2 minus y1 divided by x2 minus x1, and we have 8 minus 30 divided by 6 minus the 4, which means we have minus 22 divided by 2, which means our gradient is minus 11. So we found the gradient. Now we need to work out the angle that it makes. So we're going to use m equals tan theta. So we've got tan theta will equal negative 11, and of course to get theta we do inverse tan of negative 11 on our calculator, and when you do that you'll end up finding that it is 84.8 degrees. The example 2 says find the magnitude. Magnitude means size of the angle, the positive direction of the x-axis. Now we need to get the gradient from here, so of course I'm going to divide everything by 2 because I'm going to get it in the form y equals mx plus c, so I can read my gradient straight away. I get y equals x minus 2, so my gradient here is 1. And therefore, using the rule tan theta equals m, or m equals tan theta, I get tan theta equals 1, and inverse tan of 1 to find my angle gives me theta equals 45 degrees. When 2 lines are perpendicular, and we symbolise perpendicular with this sort of view, right angle, that's what perpendicular means, then the gradient of the first line and the gradient of the second line, when you times them together, you actually get negative 1. That's a rule, you need to remember that one. Example 3 says find the equation of the straight line which passes through this point, 1, 3, and is, part A, parallel to the line with this equation. If we're talking about parallel lines, remember gradients are equal. That's what parallel lines mean. So let's rearrange this one here by bringing this over here, and it becomes minus 3, and this one over here it becomes plus y. So we get y equals 3x minus 3, and I've worked out my gradient straight away. My gradient equals 3. It's right there. Now, gradient 3 and the point 1, 3 wants an equation of a line, so I'm going to use y equals mx plus c. I'm going to substitute, there's my x, there's my y, so I can find my c. So I get 3 equals 3 times 1 plus c. I get 3 equals 3 plus c, and I get c equals 0. So I get y equals, my gradient was 3, x, and my c is 0. So that is my rule there. Part B says perpendicular to that line. It's the same line, 3x minus y equals 3. Now remember my gradient was equal to 3. Now if it's perpendicular, then the easiest way to get the perpendicular gradient is instead of 3 over 1, we flip it, so it becomes a third, and we change the sign. So there's negative. It's using the rule m1 times m2 equals negative 1. I've still got the same point, which was 1 and 3. That hasn't changed. So y equals mx plus c. There's my x. There's my y. I need to find my c again. So I've got 3 equals 1 times negative a third plus c. So 3 equals negative a third plus c. And therefore I get c equals 3 plus the third. 3 plus a third gives me 3 and 1/3, or you could have it as 10 on 3, whatever you want. Therefore, my rule is y equals m, so negative a third plus, and I'm going to leave it as 10 on 3. Example 4, the coordinates of the vertices of a triangle ABC that show that the side AB is perpendicular to AC. So to be perpendicular, remember the two gradients, when you multiply them together, have to equal -1. So let's work out the gradient of AB using the rule. Now A and B. So I've got 3 minus -1 becomes +1, and 2 minus 0. So I've got 4 divided by 2, which is 2. Let's work out the gradient of AC, because that's the next line that we need to watch, AC. There's my C this time. So it's this one and that one. Negative 2.5 minus -1 becomes +1. 3 minus 0. Okay, which means it is negative 1.5 over 3. Negative 3 on 2 is 1.5. Now instead of divide by 3 on 1, we're times by a third. They cancel, which means it's -1/2. You can just do it on your calculator, but if you don't have your calculator, what are you going to do? Now remember, perpendicular, the gradient of the first one times the gradient of the second one has to equal -1. So we've got 2 times -1/2, and that equals -1. Therefore, AB is perpendicular to AC. And that is exercise 2G questions.